Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the Faraday's laws of electrolysis. Faraday's laws of electrolysis explain the relation between the quantity of electricity passing through an electrolyte and the amount of substance produced at the electrode. So simply, Faraday's laws explains the relationship between the quantity of electricity passed to the amount of the substance deposited at an electrode. He proposed two laws, namely Faraday's first law and Faraday's second law. Coming to the Faraday's first law, it states that the mass of the substance liberated or dissolved or deposited at an electrode is directly proportional to the quantity of electricity passing through the electrolyte. So simply, Faraday's first law explains the relationship between the quantity of electricity passed through the amount of the substance liberated or dissolved or deposited at an electrode. Let us consider a simple example. So here an electrolytic solution is taken and the two electrodes are dipped in an electrolytic solution, and these two electrodes are connected to the battery. So whenever the electrodes are connected to the battery, then the electrolysis takes place. Generally, in an electrolytic solution, the cation will move towards the cathode and the anions will move towards the anode. So what happens at the cathode? At the cathode, the cations will be discharged. That means the metal gets deposited at the cathode. So by using Faraday's first law, it is possible to calculate how much amount of the metal will be deposited at the cathode. That is directly proportional to the quantity of electricity passed. Is it clear about the Faraday's first law, students? Let us see the mathematical expression of Faraday's first law. So mathematically, first law of Faraday's can be expressed as W is directly proportional to Q. So W means the mass or weight of the element deposited at an electrode, and Q is the quantity of electricity passed, and always the quantity of electricity should be expressed in terms of coulombs, and that implies W is equal to UQ. So E means it is called as proportionality constant, or directly it can be called as electrochemical equivalent. So what is the mathematical expression for Faraday's first law, students? W is equal to EQ. Q means the quantity of electricity passed in coulombs, where E is the electrochemical equivalent. But we know that the quantity of electricity passed is always equal to C into T. That means Q is equal to CT. C means the strength of the current expressed in amperes, and T means time in seconds. So from expression 1 and 2, we can give the final expression for Faraday's first law as W is equal to ECT. So what is Faraday's first law? It is mathematically can be expressed as W is equal to ECT. It is Faraday's first law. Let us discuss about the Faraday's second law. So coming to Faraday's second law, it states that whenever the same quantity of electricity is passed through different electrolytic solutions, when they are connected in series, the mass of different elements deposited or liberated at the electrodes are proportional to their chemical equivalents. Chemical equivalents means simply we can call them as equivalent weights. Okay, chemical equivalent means simply we can call it as equivalent weight. So simply Faraday's second law can be expressed by using a simple example. So here coming to Faraday's second law, whenever two or more electrolytic solutions are connected in series, here let us consider two simple electrolytic solutions, one being copper sulfate solution and the other one is silver nitrate solution. These two electrolytic solutions are connected in series and they are connected to the battery. Then what happens? We will pass the current. So whenever the two electrolytic solutions are connected through series, the same quantity of electricity will be passed through copper sulfate solution and also through silver nitrate solution. So according to Faraday's second law, what happens? If the same quantity of electricity is passed through different electrolytic solutions, the mass of the substance deposited at the electrodes is directly proportional to its equivalent weight. So can you guess how much amount of the copper will be deposited? It is directly proportional to its equivalent weight. And how much amount of silver will be deposited? And it is also directly proportional to its equivalent weight. Is it clear about the Faraday's second law? So whenever the same quantity of electricity is passed through different electrolytic solutions which are connected in series, the weight of the substance deposited is directly proportional to the equivalent weight. So mathematically W is directly proportional to capital E. Capital E stands for equivalent weight. And let us derive an expression for Faraday's second law. So W is directly proportional to capital E means we can write as W by E is equal to constant. So here we considered two electrolytic solutions. Let us apply for both the electrolytic solutions. That means W1 by E1 is equal to W2 by E2. Let us separate the terms. That implies W1 by W2 is equal to E1 by E2. So in the present case we can write as W, that means weight of the copper deposited divided by weight of the silver deposited is equal to equivalent weight of the copper divided by equivalent weight of the silver. Then how to calculate the equivalent weights? So generally atomic weight of the copper and silver will be given to you and you are supposed to calculate the equivalent weight. So coming to the atomic weight of the copper, that is equal to 63.5. So copper and silver, these are the elements. In order to calculate equivalent weight, we must use an expression, that is equivalent weight is equal to atomic weight by valency. So what is the expression for calculating equivalent weight of an element? So equivalent weight of an element is equal to atomic weight by valency. Let us apply to this case. So equivalent weight of copper is equal to atomic weight, that is 63.5 divided by, in case of copper the valency is 2. So it is 63.5 divided by 2 and that is equal to 31.75. So coming to the silver, the atomic weight of silver is equal to 108. And here remember that the valency of silver is 1. So then what happens? Equivalent weight is equal to atomic weight of silver. So in this case the weight of copper divided by weight of the silver is equal to 31.75 divided by 108. Is it clear, students? In this way it is possible to calculate how much weight of the copper or how much weight of the silver deposited at the electrodes by passing the same quantity of electricity through different electrolytic solutions connected in series. Is it clear, students? So what is the mathematical expression for Faraday's second law? It is W1 by W2 is equal to E1 by E2. Let us see the formulae related to Faraday's first and second laws. So according to Faraday's first law, what is the expression? W is equal to small e CT. Small e means electrochemical equivalent And what is the expression for Faraday's second law, students? W1 by W2 is equal to capital E1 by capital E2. So capital E means it is chemical equivalent or equivalent weight. And coming to the relation between capital E and small e, capital E is equal to small e into F. Here F means Faraday. So we can write an expression for small e as small e equal to capital E by capital F. And remember that if the value of small e is not given, then also we can calculate the weight of the element deposited at the electrode by using the expression W is equal to capital E into Ct by capital F. And if you know the element, then it is also possible to calculate the mass of the element deposited only by knowing the atomic weight. So by using this expression, that is W is equal to capital A into Ct by N into F, where A is the atomic weight of the element and N is the valency of the element. Is it clear, students? These are the few expressions related to Faraday's first and Faraday's second law. Let me explain few problems related to Faraday's first and Faraday's second law. So coming to the first problem, the electrochemical equivalent of a metal is 0.00028 gram per coulomb. Calculate the weight of metal deposited by the passage of 10 amperes of current for 10 minutes. So initially, after reading the problem, we have to write what are the terms given and what we are supposed to calculate. So what are the terms given to us? Small e, electrochemical equivalent of the metal is equal to 0.00028 gram per coulomb. And how much amount of the current is passed? That is C, 10 amperes. What is the value of time? That is 10 minutes, and always time should be expressed in seconds. So 10 into 60 seconds. And we are supposed to calculate the weight of the metal deposited. So we are supposed to calculate W. So by using all these values, we can calculate the weight of the substance deposited by using the formula W is equal to ECT. So let us substitute the values. What is the value of E? 0.00028. C is 10. T is 600. And what is the value of W, students? That is 1.68 grams. Is it clear, students? So by knowing the values of small e, c, t, it is possible to calculate the weight of the substance deposited at an electrode. Let us move on to the other problems. A current of 0.5 amperes is passed through molten aluminum chloride for 96.5 seconds. Calculate the mass of aluminum deposited on the cathode. Is it clear, students? Let us write the terms. So the current passed through the electrolytic solution is 0.5 amperes. The value of T is equal to 96.5 seconds. and we are supposed to calculate the mass of the aluminum deposited. According to Faraday's first law, W is equal to ECT. But here the electrochemical equivalent value is not given, but we know the element. So by using the expression, that is W is equal to ACT by NF, we can calculate the weight of the aluminum deposited. So we know the value of C, we know the value of T, and we know the value of A. A means atomic weight of aluminum. So what is the atomic weight of aluminum, students? That is 27. N means valency of aluminum. The valency of aluminum is 3. And what is the value of F? F means Faraday. That is 96,500 coulombs. Let us substitute all these values in this expression. Then we can write W is equal to 27 into 0.5 into 96,500 divided by 3 into, it's 96.5 divided by 3 into 96,500. Okay, students. Then what is the value of W? You just calculate, and the weight of the aluminum deposited will be 4.5 into 10 power minus 3 grams. Is it clear, students? Let us see one more problem. Calculate the weight of copper deposited from copper sulfate solution if 5.4 grams of silver deposited from silver nitrate solution by the same current. So here two electrolytic solutions are given. One is copper sulfate solution and the other one is silver nitrate solution, and the same quantity of current is passed. That means it is Faraday's second law. So totally this problem is based on Faraday's second law. So there we have to use the expression W1 by W2 is equal to E1 by E2. So from this problem we can write the terms as, so here what is the weight of the silver deposited? That is weight of the silver deposited is equal to 5.4 grams. And it is also given the atomic weight of copper and the atomic weight of silver. So once we know the atomic weight, it is possible to calculate equivalent weight. So equivalent weight of copper is equal to atomic weight by valency, that is 2, and hence that is equal to 31.75. And coming to the equivalent weight of the silver, that is equal to its atomic weight, so it is 108. So the weight of copper divided by weight of silver is equal to equivalent weight of copper divided by equivalent weight of silver. And what we are supposed to calculate? The weight of copper deposited. So weight of the copper is equal to equivalent weight of copper divided by equivalent weight of silver into weight of the silver. So that is equal to, what is the equivalent weight of copper, students? 31.75. What is the equivalent weight of silver, students? 108. Into what is the weight of silver deposited? That is 5.4, and hence it is finally equal to 1.587 grams. So what is the weight of the copper deposited, students? That is equal to 1.587 587 grams. This is all about the Faraday's first and second law and problems related to Faraday's first and second law. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.